Hello everybody. Today we are going to work on solving quadratics by using completing the square. Previous notes we learned how to complete the square by finding the constant that would make it a perfect square trinomial. Today we're going to do that and then actually solve an equation. Again, this is from module 9.2 from your textbook, another great resource for you to use if you need some extra help looking at the material. One more time, we know how to solve quadratics by factoring and using the zero product property. We know how to use square roots, and now today we're adding completing the square. We need to remember from our last notes the square graphic organizer, the idea of b over 2 quantity squared. That's going to be seen in every single problem today. So let's make sure we got it. Solve by completing the square. This is the original way to solve quadratics. Every other way of quadratics works because we can prove it using completing the square. So we need to take the time to learn the steps so we can solve any problem that we could ever want to solve. To solve by completing the square, you have to set up an equation. Again, equations must be in standard form and equal 0. ax squared plus bx plus c equals 0. A little bit later on, we're going to see a problem where this number is not 0, but we can easily take care of that, and we'll see that in the examples. To start to complete the square by listing a, b, and c, so you know exactly what the values of a, b, and c are. Once you know the coefficients of a, b, and c from the standard form, we can actually start taking the steps necessary to solve by completing the square. Completing the square can be broken down into some steps. Here I've broken it down into 6 different steps for you. We're going to move c to the other side of the equation. We're going to divide all 3 terms by a. We're going to complete the square with b over 2 squared. We're going to add that number to both sides of the equation. We're going to use some factoring, square roots, and we're going to solve for x equals, and we're going to get either our 2 real solutions, our 1 real solution, or our 2 imaginary solutions. We will have to work with the plus and minus because sometimes we'll have radical numbers in our answer. Sometimes we'll have imaginary numbers in our answer. Sometimes we have nice whole numbers where we'll actually add and then subtract and get 2 complete different answers. The best way to learn how to complete the square is to see an example. So what we're going to do now is we're going to work through this first example together and see how each of these 6 steps comes into play so we can solve by completing the square. We're going to start with this equation, x squared plus 18x minus 63 equals 0. The very first thing that we will want to do for this equation is list exactly what a, b, and c are so we can start moving through our problem. We already made sure it equals 0. It's in standard form, so it should be a fairly easy problem to start. A is equal to 1, b is equal to 18, c is equal to negative 63. Simply start listing a, b, and c. Once you have the problem set up and you know what a, b, and c are, we're going to start following our steps. Step 1 said move c to the other side of the equation. We're going to turn this equation, x squared plus 18x minus 63 equals 0, into an equation very similar to what we worked on the previous, where we had to find the missing c value. So the first thing I need to do in this equation is I need to add 63 to both sides. I can cancel right there. We end up with x squared plus 18x plus, well, I'm going to leave a placeholder for 63 since it's gone for the constant term. I'm going to set my problem equal to 63, and well, we're going to add another placeholder right there. Because in equations, if we add to one side of the equation, which we're going to do in this space, we're going to have to do it to the other side of the equation over here. Move C to the other side. After moving C to the other side, you have to divide by A. If A is any number besides 1, you have to divide by A. If A equals 1, you get to skip this step. If A does not equal 1, if it equals anything else, we have to divide by A. If we can make sure the A value for every problem is equal to 1, completing the square is fairly simple. And this equation, since our A value equaled 1, we get to skip the division and move to step 3. Step 3 says we need to complete the square by adding b over 2 quantity squared to both sides. So, if we look at this equation right here, a, b, and c, b equals 18. So if b equals 18, I'm going to plug it in to b over 2 quantity squared in our graphic organizer. Set up in the first step. 18 over 2 quantity squared equals, simplify the quantity. 18 divided by 2 is 9 quantity squared, so we can get to 81. 81 is our new C value. That is what we need to add to both sides of our equation in order to be able to solve this by completing the square. Once we see it added to both sides of the equation, simplify the left side, simplify the right side just by adding the two numbers. 63 plus 81 makes 144. Now that we have successfully completed the square and built ourselves a perfect square trinomial, we get to move on to step 4 and start factoring to help us simplify. Our equation, x squared plus 18x plus 81, we have two choices. We can either factor it and use our super x to do so, or we can use a little bit of a shortcut. Let's see. If I were to use the super x, 81, 18, 1x and 1x, I get 9 times 9. 9 times 9 makes 81. 9 plus 9 makes 18. Looking at our factors from the super x, we would write this as x plus 9 quantity squared equals 144. Super x is great because we built a perfect square trinomial. We should be just fine. However, if we are doing a good job showing our work using the graphic organizer, you should notice, just like you should have noticed when we were finding this number, that this middle part of the graphic organizer, the square, b over 2 quantity squared, before we actually use the exponent, that is the number that shows up in our quantity right there. That is the same number that we see twice in our super x. Factoring it will verify the information every time. Using this shortcut makes completing the square just a little bit easier for everyone. Once we have our equation written in this form right here, the factored form of the equation, a quantity squared equals the number, now we can solve. Now we're going to use the skills that we learned before about using square roots and quantity squares. X plus 9 quantity squared is isolated, so I'm going to square root both sides of the equation. X plus 9 is going to equal plus and minus 12. 144 is a perfect square. Square roots. Don't forget about the plus and minus. Simplifying the right side. 144 was a perfect square, so it was easy. If we get other numbers, they could be negative numbers and we have to simplify with imaginary numbers. They could be other radicals that we just have to simplify. Always be sure to simplify the right side. Now that we have it down to x plus 9 equals plus minus 12, now we actually get to solve for x. Solve for x, simple. We're going to subtract 9 on both sides. Here I get x equals negative 9 plus or minus 12. Since 12 is a normal number that we know what it is, it's not a radical, it's not imaginary, we're going to finish this problem by making two answers. X plus 12 or, negative 9 plus 12 or negative 9 minus 12. That will give us x equals 3 or x will equal negative 21. Two solutions. Solving by completing the square is not that bad if you can follow your steps and be very careful with your work. Now let's look at 3 more examples on how to solve by completing the square. Let's take a look at example number 2. 4r squared minus 16r minus 88 equals 0. Step 1 from our, before we can do step 1 of our solving steps, we need to make sure our equation is written in standard form and we know exactly what a, b, and c are. Equals 0, so that tells me a is 4, b is negative 16, c is negative 88. Step 1 says, excuse me guys, I apologize. Let's try that again. Before we can do step 1 of our steps, we need to make sure our equation is written in standard form. It equals 0, and we know what a, b, and c are. Now that we know what a, b, and c are, we can start using our steps to solve the equation. Step 1 said move c to the other side. So, minus 88 is c. I'm going to add it to both sides of the equation. That will give me 4r squared minus 16r. Still going to leave a blank, even though it canceled and nothing is left, equals 88. And I will include the other blank on that side. Step 2 says divide by all 3 terms by a. We need to simplify, and if we get a fraction, we're going to leave it as that. In this problem, a is equal to 4. So what I need to do to every single term, the quadratic term, the linear term, even c that we move to the other side, we need to divide by a. R squared minus 4r plus that missing blank spot equals 22, plus that missing blank spot. In my graphic organizer, I'm going to show that I divided each spot by 4, so I can see what my new a equals 1, exactly what we want. That b is negative 4, negative 22, or since we moved it to the other side, a positive 22. Now that we've divided by a, we can look at step 3. Step 3 says add b over 2 squared to both sides of the equation. We need to complete the square. So, b over 2 squared. Let's set up, and now we're going to use this b value, negative 4 over 2, and work on that. Negative 4 over 2 is just negative 2. Negative 2 squared is equal to 4. This number is our new C value. This is the number that we need to plug in to both of the blank spots that we created. Plus 4, plus 4. Time to simplify. 26. R squared minus 4R plus 4 equals 26. At this point, we have a choice. We can either set up our super X and factor, or we can look at our square graphic organizer that we used and realize we have a shortcut. R minus 2 quantity squared equals 26. Now that we have quantity squared, what we just did was step 4. We factored, we wrote it as b over 2 quantity squared. Now we're going to square root both sides and simplify. Square root both sides. R minus 2 equals plus minus 26. 1 and 26, 2 and 13. 26 is not going to simplify. Square root 26. From here, it's time to use our last step and solve. In this case, we'll be solving for R. We're going to add 2 to both sides. 2 will cancel. R is going to equal 2 plus or minus square root of 21. We have one positive root, 2 plus the square root of 21, or 2 minus the square root of 21 for our 2 real answers. Example number 3. 10p squared minus 20p minus 80 equals 0. It equals 0, so now we can figure out what A, B, and C are. 10, negative 20, negative 80. Step 1, move C to the other side. 10p squared minus 20p equals 80. Step 2, if A is not equal to 1, we have to divide. Since A equals 10, I'm going to divide each part by 10. This will allow our new A value to be equal to 1. If our new A value is equal to 1, our problem gets a lot easier. Step 3 says we need to complete the square and add the new C to both sides. Negative 2 over 2 quantity squared. Negative 1 quantity squared equals 1. We need to add 1 to both sides of the equation. Let's simplify the right side. Equals 9. P squared minus 2p plus 1 equals 9. Step 4, again, tells us to either factor the left side of the equation or use a shortcut that we discovered by showing our work in the graphic organizer. P minus 1 quantity squared equals 9. Square root both sides of the equation. P minus 1 equals plus or minus, well, the square root of 9 is 3. Now it's time for me to solve for P. Add 1 to both sides. I'm going to end up with P equals 1 plus 3, or P equals 1 minus 3. That gives me 4 or negative 2 for my 2 real solutions. Example number 4, last one for today. 8x squared plus 16x minus 34 equals 8. As you may notice, this time our equation does not equal 0. It equals a different value. As long as this value is a constant on this side, we're still fine. We can do the problem. Before listing what A, B, and C are, I'm actually going to follow out and carry on this right here, and we're going to move the original C, negative 34, to the other side. Add 34 to both sides. 8x squared plus 16x now equals 42. I'm going to use these values right here for my A, B, and I will call this my moved C value of 42. A equals 8, so we need to divide by 8. One x squared plus 2x is going to equal, 8 doesn't go into 42, so we're going to have to reduce this problem. 21 times 2 is 42, 4 times 2 is 8, 21 over 4. Now we're moving on to step 3. We need to complete the square. I'm going to use b over 2 quantity squared. 1 squared is 1. Our new c value, 1, we're going to add to both sides of the equation. You have to simplify. 21 over 4 plus 1 over 1. Oops. 1 over 1. But remember, to be able to add any fractions together, we need to make sure both fractions have a common denominator. Going to multiply by 4. 21 over 4 plus 4 over 4, that equals 25 over 4. Keep it as an exact answer in a fraction. Now that I got to here, we are able to use our factoring or our shortcut step. X plus 1 quantity squared equals 25 over 4. Square rooting both sides. Well, the right side is a fraction, so we need to square root the top and bottom, numerator and denominator, separately. X plus 1 equals plus minus 5. Square root of 25 is 5 over 2. Square root of 4 is 2. From here, it's time to solve our equation. Subtract 1 from both sides. X is equal to negative 1 plus 5 over 2, or x is equal to negative 1 minus 5 over 2. Again, we are adding and subtracting fractions. Negative 2 over 2 is equivalent to negative 1 over 1. Now I can add it to 5 over 2. X equals 3 over 2, or x equals negative 7 over 2. Completing the square seems like a difficult process, but once you get the hang of it, it is one of my favorite ways to solve quadratics. This method will work for any quadratic as long as you are able to deal with the fractions that pop up in the problems on occasion. I hope this lesson made sense to you. Please try the assignment. Tomorrow, the Edulastic version of the assignment will be open, so you can check your answers online through Edulastic. Thank you. Have a great day. Stay safe and healthy.